Hello, Algebra 2. This is a lecture on kind of our introduction to probability. And so this is section 10.3. Let's go ahead and get started. What is probability? Well, probability is a number between 0 and 1 that is an indication of how likely an event will occur. And we can write these as a fraction, a decimal, or a percentage. And I have this little handy chart here. I think you guys know generally about probability because we do use this language in everyday life. When probability, we use a capital P for that. When probability is 0, that event is literally impossible to occur. And then when probability is 1, that event must occur. And then 0.5 would say, hey, we're about 50-50. This event could occur or could not at an equal ratio. And then we can use any number in between there as well, in between 0 and 1 for probability. Like I said, I think you guys know this. We will be looking at 3 different types of probability in this 10.3. One of them is theoretical probability. And this is to say, in theory, how likely is a given event to occur. So we know that the likelihood of rolling a 3 when we roll a dice would be 1 out of 6, because for every 6 dice rolls, we would expect one of them to be a 3. There's 1 success if I'm trying to roll a 3, and 6 total options. And so that's a very common use of probability for us in everyday life. We also use this kind of interchangeably with experimental probability. This would say that we did some sort of experiment, and we found out that the probability in that given experiment was maybe, was what our probability was. So let's say that we rolled a dice 5 times, and one of them was a 3. In that specific instance, in that experiment, our experimental probability of rolling a 3 was 1 out of 5. We know that that's different than the theoretical probability. They're not always going to be the same. But in our experiment, when we were trying to roll 3s, we succeeded 1 time, and we had 5 total trials. Therefore, it's 1 out of 5. There's this thing called the law of large numbers in probability that states that as the number of trials gets larger, the experimental probability should start to get closer and closer to the theoretical probability. So that's called the law of large numbers, and we'll talk about that as well a little bit. And then finally, we have the geometric probability. And this is going to require you to calculate some areas. Basically, what you're going to do is you're going to take, let's say we have a shape. Here's the shape. And then maybe we say, hey, that triangle is the success. So what is the probability if we randomly picked a location, or like we threw a dart, if we assume that every location has an equal likelihood of being selected? What is the probability that our dart would land in the triangle? That's what geometric probability is stating. So what we're going to have to do is we're going to have to find the area of the success and then divide that by the total area. We're going to have to find the area of certain shapes then. I would expect you guys to know the area of a triangle is 1/2 base times height. The area of any rectangle would just be the length times the width. And then the area of a circle would be pi r squared. And so I could ask any of those. Consider those fair game on a quiz or a test. In 10.3 and in chapter 10, I'm also going to ask you to find odds. And I feel like in everyday language, we use probability and odds interchangeably, but mathematically, they're not the same thing. And so let's go over, highlight the difference. Probability is comparing the number of successes divided by the total. And what odds compares is the number of successes divided by the number of fails. And actually, I very rarely write it as a fraction, although it could be written as a fraction. You're typically going to see me write it as number of successes colon number of fails. And then odds against would be the number of fails compared to the number of successes. And so typically, I'm always going to use fractions to represent probability, and ratios written like these down here to represent odds. So you're going to kind of have an idea of which one I'm referring to. But the difference between probability and odds is probability compares successes compared to the total number of possibilities, where odds is going to compare the number of successes versus the number of failures. So let's look at a couple examples. Let's say that we're randomly selecting a number between 1 and 20. Question number 1, what is the probability of randomly selecting a multiple of 3? So remember, when we're talking about probability, that is the number of successes compared to the total number. There's 20 numbers between 1 and 10, so I know my denominator is going to be 20. I just have to figure out how many numbers are multiples of 3. So we would have 3, 6, 9, 12, 15, and 18. So there are 1, 2, 3, 4, 5, 6 ways to succeed. If you leave your fractions unreduced or your ratios unreduced, if we're talking about odds, you are going to get partial credit. These need to be reduced and reduced properly. So 6 out of 20 would reduce to 3 out of 10, and that would be our probability of selecting a multiple of 3 if we are randomly selecting a number between 1 and 10. So on to question number 2, what are the odds in favor of selecting a prime number? Okay, so odds in favor is going to compare number of successes to the number of ways to fail. So how many numbers are prime in between 1 and 20? Well, 1 is technically not prime. So I don't expect you to know that off the top of your head, but let's disregard 1. The numbers that are prime would be 2, 3, 5, 7. Just as a reminder, prime means its multiples are 1 in itself. So 7. 9 is not prime, but 11 is, 13 is, and 17, and 19. So I've listed all of the successes. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 ways to succeed in this. And if I know there are 20 total numbers and 8 of them are successes, that must mean that 12 of them are fails. I could list them if I needed to. And as I stated previously, you do need to reduce your answers, whether they're probability or odds. These are both multiples of 4, and so this would reduce to 2 to 3. And then lastly, this is not our last example, it's just the last one on this page. What is the odds against selecting a multiple of 5? So odds against would be fails to successes. So how many ways are there to fail versus how many ways are there to succeed? Well, if I'm looking to draw a multiple of 5, the ones that would be failures would be 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. Hopefully you guys agree with that. 4, 8, 12. There are 16 ways to fail at this task. How many multiples of 5 are there? Well, there's 5, 10, 15, and 20. So there'd be 4 ways to succeed. We do need to reduce this if we want to have our right answer. So this would be 4 to 1 odds against drawing multiple of 5. We have 2 pages left of examples here. Great time to pause and try these ones out. It is going to be beneficial for you to have some background in a standard playing deck of cards. I do have a board in my classroom where I give you some card facts. How many cards are there of this suit? How many face cards are there? All that fun stuff. So you can have that cheat sheet if you need it, but hopefully you do have a background in a deck of cards. So when randomly selecting a card from a standard playing deck, what is the probability of selecting a 3? So we need to know how many ways are there to succeed in drawing a 3. Well, there are 4 3s in a deck: 1 spade, 1 heart, 1 club, 1 diamond. And then how many total cards are there? Of course, there are 52, hence 52 pickup. And we need to reduce this to 1 out of 13. That would be the probability of selecting a 3 if I was randomly going to select a card from a standard deck. What are the odds in favor of selecting a face card? This is one of the card facts that's in my room. There are 12 face cards in a deck. There are 4 hearts, 4 kings, 4 queens, and 4 jacks. So there are 12 total ways to succeed in drawing a face card. And then if there's 52 cards and 12 of them are face cards, that means that 40 of them are not face cards. I did draw a fraction here, but I don't generally do that. I'll generally do the 12 to 40. I'm going to reduce it and write it in that form. They're both even, so I'm just going to divide them in half. 6 to 20, they're still both even. I'll divide them in half. 3 to 10. That would be the odds in favor of slicing a face card. And then lastly, what are the odds against drawing a spade? How many ways are there to fail when I'm drawing a spade? And then how many ways are there to succeed when drawing a spade? So 13 of them are spades. And I know there are 52 cards, and 13 of them are spades. That means that there are 39 not spades. Both of these numbers are multiples of 3, so I can reduce them. Sorry, both of these numbers are multiple of 13, so I can reduce them to 3 to 1. That's the odds against drawing a spade. Last example. Let's do one geometric probability example. It's good for the soul. Assume a dart is equally likely to land in any location on my dartboard over here. It's a very odd dartboard. What is the probability that the dart lands in the red region? What you're going to need to do is find the area of red region divided by total area. And I gave you the radii for both of these circles. The smaller circle has an area of pi r squared, and r is 4, so pi times 4 squared. The yellow circle has an area of pi times r, 16 squared. And so this one would have an area of 16 times pi. I square the 4 and got 16. And then 16 times pi, I can just write as 16 pi. And then 16 squared is 256. So the denominator is going to be 256 pi. A little math trick here, I could type in 16 times pi and then divide that by 256 times pi. However, I know that the pi's in the numerator and denominator are going to cancel. And I know that 16 divided by 256 is just 16. So what I end up with is a probability of 1/16 that this dart would randomly land in the red region. That's all I have for you guys for section 10.3. Please let me know if you have any questions.